Hello. Welcome. I think we're good. Adjusting levels on my end. Alright. Here we are. Another week. Another awesome week. Late in the summer. In the year of our newly appendage 2023. I'm Agents Ultra. We're here to work on a game that we've been working on called LambdaTrek. It's a clone of a really old game in the ancient times called Trek, or Super Trek, or Star Trek, or whatever. It's had many variants and clones over the years, and this one's no different. The only thing is, we're building this one in Haskell with the wonderful brick library. And if this is your first time tuning in, the project looks like this so far. Let's go over to LambdaTrek, yeah, and we're gonna exec LambdaTrek this. Cool. So we got the S is our little ship. This is kind of our map of the area. A little quadrant. There's an enemy ship here and a little star. We have our like information display over here. We can input commands, like we can move. Next to that enemy ship, we can fire our phasers. With like 30 damage, we destroyed the enemy ship. And we left behind some wreckage. Pretty cool. We can try and move into spaces where there's like stuff in the way, and we can't. Same with that star. And things like that. So we can move around the sector, or the quadrant. We can destroy ships, blow them up, and all of that stuff. What else do we need to do? Well, we have lots we need to do still. We got to enable game over state. So if you run out of energy, then that's too bad. You're adrift, and that's game over. Which is, I think that's what we were working on last week, if I recall correctly. We're getting started adding different states to the game, like the main game loop. We might be in like a game over screen, or we might be in a different screen, and we're eventually probably gonna have like a title screen where you can set up the game and begin playing. So yeah, figure this out here as we go along, as we do. So in our game state, we had this idea of like game screens, separate game screens. And it's a little bit different than when we did a game a while ago called Haskell, where we sort of started setting this up, where we were able to kind of create our own little state machine here for our main game loop and switch to different game states by having that sort of encoded in the structure. However, we don't control the structure entirely with the brick library. It's kind of a retained mode style kind of library where it's very declarative. We can give it some state, like our game state, and it can hold that whole structure in it, and we can do updates in reaction to events to the state. And then we can render the state. But we don't necessarily control that whole loop. So, instead we're going to have to like kind of have a way to, I guess, check which game screen we're on and flip into a different screen, render a different screen, render a different state, do different things, react to different events, depending which game screen we're in. I'm gonna get my builder going. Let's go. Oh, maybe we'll just do the build through the test runner. Try and keep those up to date as we go along. Handy dandy water. Okay, let me break out chat here and make sure that I'm paying attention to your chat, because loves ya. Kidok, go. About the up there. Okay, it's just some off-screen stuff. Take care of. Okie doke. So that's kind of the plan of attack. The game state screen is going to kind of determine which game state we're in. The only, well, actually, only other way I can see us doing this would be to make game state. No, we need some global things, because if we're in, yeah, if we're in this the quadrant screen, doing long-range scanning and stuff, we still need to be able to know things about the different sectors, so we can't have that. So I was thinking of maybe making this like a sum of records, but with different game states, but no, it's not gonna work. Okay, so let's just go down this path. So what we want to do when we have game over, well, in our UI and such, we want a game over UI. I think UI here is kind of our main UI. And we're gonna have like a game over thing. Okay, so we'll do sim display is like probably a bad name for actually like sector display or sector screen. So actually I'm gonna rename that, yeah. Let's do that. Call it sector screen. That shouldn't bother anything, and that should recompile no problem. Sim display. Okay. And let's do our game over UI. We could just put it underneath here, why not? It's going to be pretty much the same type signature here because we need the game. Still need the game state for the game over screen, so we can display the score, things like that. And game over display. Well, we don't really need to have a separate thing for that, right? We can just do just ignore the state for now. Join borders with border style. In fact, we almost want this all to stay the same. We just want to make this part a parameter. This expression from 82 on. So we will just do stir. We'll just make it stir lambda game over for now. That's the smallest, easiest thing we could do. Okay, so the next step, let's just add that. We want to then make this a parameter that we can switch out. Or at least it should detect which screen to render. Yeah, that's probably what it should do. So let's get the state out. How do we get the game state? Yeah, I forget. Let's look it up. Form state. Okay, form state F, I think. And nudge that all over. Okay. And then game screen. We can case match here. Yeah, why not? Game state. Game state screen. Yeah, that's right. Feel. We got second screen again. So if it's sector screen, we'll just take this cat. And that should be an arrow. And then if we're game over screen, and that should be an arrow as well. Pardon me. Let's see, huh? Right, and then probably doesn't need to break this around it anymore. Okay. So then, in order to render our game over screen, we have to just like change the game state to show the game over screen. And we'll need to do that in a number of places. But one place would be best. First, let's commit this. Render appropriate game screen based on the game state screen. Okay. Let's see now. What's the next part? Let's go to where we handle the commands. Those are the actual command definitions, sorry. Simulation. Okay, so we can do it maybe here in the update simulation. Or, what was the other place? I think we could maybe do it in the UI too. No, sorry, maybe the main app. This is kind of like a high-level part of the system here. We could add another part here where we check for game over state. Okay, so check for game over doesn't exist yet. Of course, we have to do that. We have to implement that. We'll probably just... form, state, name. Is that the right side? Oh, what's the type? Do. Let's call it int to int. That's not right. Aha. Expected int to form game state. Interesting. Update form state. What is that returning? Interesting. Oh, what? There. Maybe it is returning an int. Weird. Sorry, I'm just confused about that. I think that is reporting it to be. Let's check it out. You know, for some reason the chat isn't working. I'm not sure. Hopefully nobody is trying to get a hold of me yet, but I'm not seeing anything. So if you're here, just type a little something for me so that I know if something's going on. If I need to like reconnect that or something, or pop it out, pop it back in.
Outcast to the mainstream, our order numbers have thrived in recent times. Finally, the time has come to unshackle the beast that mankind has feared for so long. Relinquish your fear and submit to the cause.
I'm gonna test my stuff.
In these audio recordings.
Well, I'm chatting, and that's okay. All right. Well, hopefully I can see yours if you've got any questions and stuff. I'm not ignoring you. Trust me. Okay. Where were we? Okay, it wants this, like, really funky function here. A game state to game state to game state. It wants it to be this. Now, I don't know how much I trust that. That's kind of weird. Okay, it's got to be this update form state function. Is that coming? That might be coming from the library, but perhaps. Haskell. Click. Update form state, yeah. Okay, that is coming from there. Some S. Form state. Okay, so a game state to form SEN to form SEN. Okay. So the reason why this doesn't work well here is because that's probably taking our S. And let's move that. Because modify wants different function. Okay, this looks a little better. Okay, so yeah, this function ought to work. We go from game state to game state, and if we detect the game over game state, we can just set to the game over screen. We can set the screen to the game over screen, basically. So let's pull in the game states. This, such that the game state player ship. And I want that to be the energy. Less than or equal to 0. We want to take the game state and update the game over, or the game screen to be game over screen. Otherwise, we will just return the game state. Now, this probably not all working the way it's supposed to. Let's go fix that. Near. So, ship lens. Energy. Okay, not in scope. Not in scope. Okay, so we got to bring some of our simulation types in here in order to do this. We are importing them from here. Let's make the simulation re-export those. Or we could just bring them in. Let's just bring them in. Simulation.ship. And state. No, that doesn't. No, that should be in the state module. The state modules. Yeah, its lenses are kind of weird for some reason. Sort of. Maybe like that. Okay. Game state screen. So dot tilde. Should be tilde dot. Lens.micro. What is it? Lens.micro. Resets. Function. Assign. Okay, so it should be dot tilde. That's assign. Okay. So this is the problem that people often talk about with lens and using lenses, is you get these wicked cool type errors. Couldn't match type game state with like a2 to data.functor.const a2 what? This might be because the way I'm composing things together in this expression here. I'm gonna pull that out and just put a hole there. Okay, so this is still, I think maybe I have to compose them in this order. Okay, why don't we do it with a let binding? Game state ship. if the ship energy is less than or equal to 0, then we change the game state. We set the green game state screen. Yeah, we set the game state screen to game over screen. Else, just the game state, please. Okay. There we go. Okay. And we should be able to, like, run out of energy. Let's use 98. Ah, cool. There's our game over screen. Let's try that again. Just make sure we can't input other commands. Not that it matters. We're not rendering anything. But I think the form will hopefully not be updated from that point on if we're not rendering it. That's my only concern with the setup so far. So I'm going to commit that, and then I'm going to update this, I think, just to test this theory and make sure that this is not what's actually happening. When the player ship runs out of energy, which over. And there'll be other conditions too in the game, like obviously being destroyed and running out of time will be another one. But this is good enough for now, just to kind of like get the balls rolling with that. So let's see, what else is there? Yes, let's render more stuff in the game over screen. So pull in the African, we'll get the game state out. And from that, we'll get like the we'll render the ship energy, say. And do that with go on the game state energy of the ship. Dot energy is what I meant. Yes. And the problem this is game state doesn't have the ship. Pose it this way. Nice. Yeah, so when you compose the setters, the like the lenses themselves on the focus point, the normal composition order that you would think of in Haskell is kind of reversed. So you'd imagine this is at the right hand side's getting the game state first, but it's the other way around with lenses. So a little weird, but worth noting. Yeah, so now if we do this and we die, or we get game over, we'll move close to our little enemy ship, Fire phasers, 98. And if I try and type the same command and do 10, it should not change anything. Okay. Cool. So the only thing it's responding to there is escape from the game over screen. And that's because I think at the higher level in our app, we handle event. Maybe it's an update simulation that we're doing that. That would be interesting. Check simulation. No. Is that just a brick global thing? It just responds to the escape key, maybe. Oh, there it is. Yeah, so we globally respond to the VTY event, escape, and just call halt. Okay, that's good to know. Okay, there you go, game over. Maybe we could do a little bit better with the UI, the game over screen. How do we make it take up as much width as we need? Oh, there's an interesting one. We should... Well, I think that's good enough. Let's commit that while we have it. Okay. That's good. Let's see, what else do we need to do? So let's, now that we've got the game over screen, if we're running out of energy, we should probably be able to, let's do space stations, right? Space stations in Trek, that's how you recharge your energy. So let's go to our sector. And let's have some space stations. Let's do it as an array, just like we do with enemies. Okay, we don't have a station yet, so we need to define that. Let's create a module for it. LambdaTrek simulation station. All right. Let's give the station a I think in Trek, they had like a certain amount of energy to give out. They didn't like fully charge you. And it's going to need a position X. Okay. And I might even put that up there. Okay. And then we have to import it here. And doop, 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 doop. Okay, this needs to have an ord. There we go. And that should make compile now. Well, no, not quite. Oh, okay, yeah. In our empty sector definition. We'll do the same thing again here. We'll do a single station. And we'll make it at 9, 1. Oh, and a certain amount of energy, let's say 100. And of course we need the actual constructor. Yeah. Yeah, that's fine. So, like, obviously there's, like, coordinates for positions that don't make sense, right? The station has to be inside of a sector, and the sectors have a fixed coordinate system that's not infinite. All right, it doesn't span the full range of integers. So the values here for x and y, there's a lot of them that are invalid. And if I was a little bit more defensive about this code, I might write like something like a smart constructor there for it, but or a better, maybe even a type, so that I can't mess it up in the future, and maybe help myself later on. Yeah, for now, the game is pretty small, so I'm not gonna worry about it too much at the moment, but that's something you might want to consider when you're working on your own Haskell projects. I would probably consider starting with that if this was already a fairly mature code base and I was working with other people on the same code base, where they might be editing and changing the way sectors work and the logic there in a different change that I'm not aware of. And so if I'm designing that up front, I might design it with those types. Just so that it's part of like the contract and the API, and like it becomes kind of obvious how to construct sectors in the right way without breaking anything in the game. But since it's just us, we're okay for now. In this case, I might consider it later on when I start making mistakes and slowing myself down. I'll probably do as a refactoring step. Okay, so digression over. We have a station in our empty sector. This all compiles now. Let's commit that. And stations we added to can appear in sectors. And have some energy to recharge player ship. Okay, and then we just need to render it. That's the next part. Oh, so we need a tile for it in order to render it. Render tile. Tile. I don't know why it's in simulation, but it is. Okay, station. Let's render it as I don't know, like a dollar. Pretty good. Okay, so that's the tile for it. And now the UI is probably complaining because we're trying to render. We're missing a case. Ooh. 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 What's this? Oh, we're just not using that yet. That's fine. Okay. This is the one I was thinking. Sector 34. Ooh, okay. Yeah, so we import the tiles here for some reason? Oh, because the rendering the thingy to get the sector tiles. Okay, yeah. And we name the tile constructor the same as the type. So let's import tile. We import it qualified. Yeah, we already have that, so let's just do that. And fix this here. Actually, no, let's just not import the constructors. We'll do it like this. Yeah, that'll clean it up. Not bad. There, and there. Okay, we're good. Back to green. Like it. It's like my favorite way to work. You make one tiny change to the code, you get it compiling again. You make another tiny little change, you get it compiling again. And having like a totality checking and stuff like this well, it's not like totality checking, but like coverage and like a whole program analysis, and so it's pretty handy. Even though sometimes I guess on large Haskell code bases it can get quite slow sometimes. So you need extra tooling there, but for small projects it's really good too. It's getting better on larger projects thanks to a lot of stuff that we do at work. Yeah. Any hoozle. Let's see, that's all good, so let's commit that. Station tile. We're building the sector tiles. We need one for... We need the... blah, 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 blah. Stations. Yeah.
We've come to the place.
So we're only having like a
Joke about the idea of the devil.
triple layer of
Horns,
stuff
hair,
here.
all that.
So we're building the sector tiles, right? The starter tiles, we set the ship. That gives us the next tile map with the ship set. And then we fold over that, over those sector stars, add the stars to get a next set. And then we fold over that, finally, over the enemy ships, updating the star tiles. So if we want to add another step here, we can go enemy tiles.
If you have the slightest bit of greed in your heart, he will turn
Is this.
an avalanche. He will
And let me just yank that whole bit out. And then at station, enemy tiles, sector stations. And station. It would be cool if we could destroy stations and stuff, or the enemies could. But for now, we're just going to unsafe set tile the station on there. And we're gonna have to pull out the station position X and the station position Y. File that station on files. Nope, stations is not the thing I called it. Sector stations. It's saying that we can't match type station with enemy. Oh, I messed up the type of my function. this problem again. I wonder what the heck is up with that. The whole make fields thing that we've been using with microlens is supposed to make these sort of generic lenses using these like kind of has position X classes that get generated for it. And so it should automatically be deriving that instance or generating code for that instance for us, for our station type. But for some reason it's saying it's not in there. Yeah, maybe it's, if I type it out like this. Let's see, let's look at our station definition. Oh, we didn't make lenses for it. That'd be why. Dirt. Let's do that quickly. That's whew. We're going to need a few type classes up here, I think, or language extensions. Template Haskell and a few others, I'm sure. I'll just try and grab from maybe ship. We need that. There we go. We don't need that. Maybe don't need it in ship either. Before this starts, it's getting a little messy here. Let's not go too much further. Let's just get back to green here. Now the problem is... yeah, that's still saying that. Okay, yeah, it's still a problem here. See if we can do it the way I thought before with the qualified station. Okay, that one seems to be okay. So we have to fully qualify it. That's really annoying. I gotta figure that out. Okay, we're back to green. That's happy. I like it. Alright. Let's get that all committed. Two build sector tiles. And I think that'll, I think that might be it. I think that might be all we need to render our station there, and there it is. Okay. Sweet. Okay, so next we need to handle collisions with stations. We shouldn't be able to collide with them. So we go over to simulation. We need a new collision case. Collides with station. Ooh, collides with stations. Where are that? Almost gonna be exactly like Emmy. Substation. That I might even need just basically that whole chunk. Naming this stations. That and this. Oh gosh, repeated code. Oh no. What are we gonna do? And that one and that one. Okay, let's bring in the station. Fix that. And qualified. Okay. So we're not using it yet. Okay, so let's add a case here. This code's getting a little nesty. So if we wanted to extend this and keep going with the pattern, with the way it's going right now, we need another case, I think right here. Or here. I might want to make this code better. I think we probably want to do what we did for the combat module and refactor pretty much all the command handling into a state monad. That might make less nesting, but I'm gonna just keep going with rolling with this, I guess, and then we'll do that maybe in a follow-up step we have time tonight. So let's go. So we have else. In the nothing case, we need another case. We need a collides with stations. We take the array elements of stations, X, Y. Clids, Clydes. Stations. Sector. Yeah, that's going to collide. That's annoying. I should probably call it something else. Underscore on it. Yeah, for now. I don't want to mess around with naming things at the moment. Not while we're on a roll. Okay, now we just have pattern matches not exhaustive, so we have the just case where we just have the station. And if we have the station, we can add the dialogue to the game state from Helm. Captain, we would collide directly. We'll collide with the station at X. Y. We don't really use S here, so we'll just ignore it. Okay, and if we implemented this correctly in the right spot, then our game should still work. So we should still be able to move to an empty space, like move 1, 1. That seems to be fine. 0, 0. Move 14, 14. We're good. There, we're no good. 9, 1. We should get station. Yeah, we would collide with the station at 9, 1. That's good. That's what we want. Super. And then we want to be able to move next to the station. Bueno. Okay, so that's station movement there. Now collision with the stations. So let's commit that. Station collision detection. And handling the move command. And you don't move. Key. All right, so let's try and do a little tiny refactor here. Let's see if we can't get away with this. So the goal of this refactor here is to get rid of the nesting here of all these cases. Right, if we have a collision event, we just want to handle that collision event. That collision event's just going to either update the state and like it's going to modify the state somehow and then return. Right? If there's nothing to modify because there's no collision, then it does nothing to the state. Or maybe it adds a message. But it's up to the collision handler. And we should be able to break out these different collision things into their own functions and then compose them in here and remove some of the nesting. And that will be that. We won't try to like go overboard here and like make all the dialogue generic and stuff. We just want to remove some of the nesting so that if we're going to have other collision cases and events, and we don't have to keep going off to the right of our buffer and that kind of thing. It just won't be tenable. Okay, so in order to do that, this is like one of the things that monads are pretty good at, is like removing nesting in code. So let's start with simulation state. I think maybe we can just change the type here. We're going to make a bunch of things red. Things aren't going to compile for a while. And we want to get back to green and combine them as quickly as we can. So it helps to go in baby steps as well. Right, so now, because we're in state here, we're not going to return a game state. We're going to update a state. I think we can get rid of this as input. And then we can lens.micro.mtl and the MTL lenses will let us kind of focus in on a particular part of our state, our game state. As you may recall if you've seen previous episodes in the stream, yeah, use, okay. So we go command, use game state command. What we'll do here, change this to command. This is going to propagate down quite a bit, so we're going to be red for a while, I think. But actually, we won't. This actually will become a lot simpler, this code here. We can get rid of all of this. We can just do handle command. Update simulation is basically just handle command. Oh, it's maybe command, right? Because of the form stuff. So in that case, we just do pure nothing. Okay, and this is also kind of interesting because it's showing how monads like infect code, so to speak. So notice here, like, I don't have a game state in scope, so I'm going to just remove that. Wait, what was this bit doing before? Hang on a second. Right. Yeah. So, sorry. Yeah, so this state is going to like kind of propagate things downwards here from update simulation. And handle command before was kind of pulling out parts of the state so that we could kind of simplify the signatures for engine move can be handle engine move, and they kind of have a similar structure. Jump move doesn't do anything, and so on and so forth. And so we're threading down the game state manually. But now all of those are going to be implicitly passed through the state monad. We don't really have to pass that explicitly anymore. And this branch here just has to do the handle the command, and then set the actual like game command back to nothing in the form field there. So then we can use set here. Back to nothing, and then handle command doesn't even need this stuff anymore. Alright, but we're still gonna counter match on the command itself, so we're gonna pull that into scope here. Here. Pop those over there. See, and we're kind of going down the stack here, so handle engine move now doesn't need to be threaded game state manually anymore. Jump move's not going to do anything yet, so we're just going to return fire phasers. So this already has an exec state because it's using the state monad itself. But we don't need to anymore. Right, we can just handle fire phasers. Except this is probably going to be like a name clash thing. Oops, I forgot to change the type here. And that's going to be maybe command. That's why we pulled this out. Yeah, let's put that back in. Make this back into a Lambda case. Get a little ahead of myself on that part. Okay, so then we got to push this down here. Handle engine move now. Doesn't need a game state. Just needs the input X and Y. And needs to change this to a state. State unit. And this can become use. This can become use. And this can become use. And that's nice and handy. Okay, and now our sort of duplicate add dialogue command function thing is also going to become a little bit redundant. Which is nice, because that was a bit of duplicated code. That's over in simulation, dialogue, and now we can use... Oh, where did I... No, that's the definition of it. Use it for a bit in combat. Where is it? Let's just search for it. Yeah, there we go. Right. That's the old dialogue, definitely there. Stay dialogue is the one we can do now. That's right. So we can change that all to say dialogue. Don't have to pass a game state, just the crewman and the text. I think we can go ahead and turn on that one. Okay, and then in this case here, we have the nothing. We can just use the set. So dot equals. Okay, and we're pulling out the ship here. So we'll pull the ship up here. Game state. Or is it player ship? Game state ship. Make this ship. The energy. And okay, and then this is stop. It's gonna stop working so well. Let's see, this one is... Oh, we changed the meaning of something here. Undo that quickly and say center type that. Oh, that should be all fine. Yeah, no, that was fine. What am I doing here? We're gonna get rid of this. carrot view, the shift on energy -2. Okay. So I changed something about stars and I changed the expression in line 41, I think. Probably what happened here. So reviewing the game state, and do we get out the stars? Oh, did I change the type? No, I did state, game state, yeah. XY, okay, yeah. This should be a synonym for what we had before. Maybe the composition doesn't work quite as well with use. Pre-use. Pre-use or is preview, which implicitly operates on the state. It takes the state and applies a traversal or hold to it to extract the first element the traversal points at. So we give it a getter. And then maybe, oh, that's like, okay, like a prism kind of thing over the state. This is nice. I like this. Okay, but for some reason it's getting a list. Not what we want. Oh, maybe it's because of this. Okay, maybe we do. Yeah, so I think this is. Yeah, I think this might be the one. Let's grab that one, and that one. It combines. Ah, okay. Okay, we still got some problems. lined up with this one. This one. Lined up with that one. Lined up with that one and that one. Okay, and this is probably fine in this module. I bet it's complaining about something else. Update simulation, yeah. Okay, so where we're using update simulation, I think we propagated down far enough, it looks like, that now we need to propagate back up in order to pass in the state. And that used to get threaded through manually. So where we call update simulation in app, that's where we're going to do it now. Yeah. Okay, so here where we're gonna pass in the states. Something ugly like this. Really gross. Just disgusting. There's the problem here. Right, so this pipe here for modify, update simulation was previously getting the state as input, returning a state, game state. Alright, so, oh, we want S prime here, that's why. Still gross? Still gross. Why do we not like it? Exec state, maybe it's the wrong one, maybe? Well, we don't want the value, we want the final state, yeah. So exec state should be the one, that returns the S. Alright, so it takes our... When we flip it around like this, it takes our initial state, which should be this. Right, and... we just had to put a parentheses. And this ugly duckling is going to get the same treatment here. We're just using a state monad, just in the places where we need it. We've increased the scope of it where it's needed a little bit, but not much. Okay, so now update simulation has a problem here. It's applied to one value argument. Has none. Where is this? Oh, in tests. Okay, so we have to fix the tests. That's why we have the test runner running. And then I think That will bring us to the end of the screen as we get that going. So let's get rocking. All we have to do is kind of like the similar stuff. Let's call it init game states. In fact, let's just rename it initial game state. And that should be init game state. Bring that over a little bit. Up, go, boom. Okay, and then to make this one compile again, we just do a similar thing. We're going to exec the state with the initial state with valid move command. I think that's all. Maybe not. Oh, sorry, valid move command. My bad. My bad. And then... Uh, 49. Oh, init game state. Wow. Whew. There we go. Okay, we're back to compiling. All the tests work and still everything's good. So our refactor was a success so far. Close, not quite though, because now we can clean up some things here. We'll take it a little further. So our real goal is to get rid of this nesting. So let's commit this state of the refactor so far. Since we're back to green. I'll mark it as a work in progress, so I remember to rebase it before I push. Hopefully. I'll put a refactor label on it. Then we'll say that this is like update simulation into state T. Okay, and so the next part of it is that these different collision handlers should be able to now be these state functions that we can then just stack one on top of another. What I want to be able to do is like handle star collisions. handle enemy collisions, and then handle station collisions like this. And then we should be able to break all of this code out into smaller little chunkies. So we'll comment those out first, and we'll start with handle star collisions. And it's going to be a state with game state. Unit. We can probably use that handy dandy zoom stuff now. So we go to MTL micro, zooming. Super cool stuff. We zoom into just the part of the game state we care about. And update that. That would be super neat. For stars, we just care if collides with stars returns true. Yeah, huh, okay, so... I see. The handle star collisions is going to need the input parameters. Like this. And let's zoom on the... No. We can reuse maybe collide with stars. Maybe we can just bust this down. About like that. Seems alright, maybe. Okay, so collides with stars needs the list of stars. So let's just get the list of stars. Game state sector. We know what to do in this case, just nothing. And in that case, we can just bring out this say dialog here. That should be fine. And then we can get rid of this if. We'll pull this back over here. and remove a little bit of indentation. So our refactoring is working so far. I think this will compile just fine. And the nothing case there. With a just case here. Nothing case there. Okay, so that's one level of indentation gone. A little doohickey on it like that. Okay, back to green. Sweet. Okay, next, enemy collisions. Collisions. Yes. Int. Int. There we go. Yes. Yes. I should really come up with a pattern for doing this. Anyways, X, Y. And do. We're probably going to want to pull out the enemies. And like that. Yeah, and then we're going to copy that, jump down here. Okay, got a couple of holes. I'm going to copy those almost exactly. Bring them down here. Lines with enemies, and this. Bring those out. And we'll pop them down here. With a little wear clause, of course. Wear. You don't like this. Because that's not in scope. Oh, enemy ships. That's what I called it. Ah, smarter there. Yeah, good. And in the nothing case here now, we don't have to do anything but just return. Then we can get rid of this code here. And all of this. And this. Another level of indentation gone. Cool. Get rid of that. Now we should be back to green. There we are. So just one more to go. This is a good sign that we're on the right refactoring here. And then handle station collisions. Much the same. It's very mechanical. Alright, int, state, unit. And go up there, grab our station code. Back there. And we'll basically just grab this. And then we'll grab the where clauses here for collides with stations. Put it down here. Okay, and then let's see. Let me see, ship. A binding for ship. Let's use it up here. Pull up the plug here. Now we should be back to green again. And there you go. So, let's just give it the old kick the tire, make sure that the refactoring worked as expected and didn't change any behaviors. So if we go to 7.3, we should still have our move command there. That's good. Let's check moving to 9.1 and trying to collide with the station. We would collide with the station. That's just as before. 8.3. Oh, we found an error in the program. That's okay. Let's try the star. 10. 10. Yeah, the star at 10. Okay, that's good. Okay, so we can move into the enemy ship. I'm not sure if that error was present before. I don't think we changed collides with enemies. We might have changed the bindings of some things. Let's see, huh? Yeah, let's check our diff. Let's double check that. So pre-refactor, we called collides with enemies. We gave it XY, which is the input to the handle star collisions. Or sorry, what was there? The function that was there before. Handle command. Handle engine move. Yeah, okay. So handle engine move, XY passes it right on to enemy collisions. Check if the enemy is destroyed, otherwise we say this dialogue and just return. Oh, I think I know. We did introduce a bug in this refactoring by doing this refactoring. So, because these save functions are now like they're not returning early. Right, like early as in like if we like do this action here and then we add some dialogue. All right, then we do this one, and then we do this one. But we always do all of them. Right? Whereas before, when we were doing the case matching stuff, it would get down to the final branch where we had the space clear, and we could actually do the move. Alright, but we're doing that now in handle station collisions. When we do collision with enemies, we're saying like, oh yeah, we collide directly with that enemy ship. And then we're going to the next function, handle state collisions, which doesn't check for enemies, whereas before it was because of the way things were nested. So we need to fix that before we can call this complete. We either need to... What do we need to do? We need to have... So this branch here is where the error is. So we need a way for these functions to either to signal that there was no collision, that's one way we could do this, and their only job is to add the dialogue. Or we need a way to jump out early from the whole thing. Have like some kind of early termination kind of thing. I don't know the way I want to do it. So I'm going to pull this out here. I'm going to turn pure unit here. We could return a value here, like a boolean. Make them all booleans. May not be the best way, but true booleans suck. Let's not make booleans. Make a type like did collide or collision results. So return collision results, and then they're all empty, then we're good. Missed. And this is collide. And this will have to be a do. And this similarly. And this will be next. And here. And missed. Okay. Okay, so then we bind those results. With patience. And something dumb, we could do all three of these. Just make it work. Not pretty. It's the only case we care about here where all of these are missed. Then we can do that. Otherwise, we do nothing. A parse error, maybe? And I'll put a ship and let's go up here. Alright, back to green again. Okay, and now that error should be gone. So, yeah, now we don't actually move on top of the ship. We don't move to the station, and we don't move onto the star. Good, but we can move next to the enemy ship, no problem. And we fire our phasers. We don't have that much energy. We destroy the enemy ship. Energy went down to 59. Boom. Sweet. Let's commit that. There's probably a... cleaner way of doing this. But I think we're out of time, so we're gonna have to look at that next week, maybe. This is good enough, at least. It works. And we successfully reduced all of that indentation. So now when we want to add more collision checks, we can just add another line here, another line, and it won't continually go out towards the right. We might want to deal with this, though, and maybe do an early termination thing. But we'll figure that out next week. This has been a pleasure. I am miffed with our progress. We've done some good work tonight. So this is the final refactor, commit, break out collision functions. And yeah, so I think we did okay. We will, when apply this change, we'll change, update simulation, state T. Welcome, Nixflix. Did I do a game in Common Lisp a couple of days ago? No, I did not. That wasn't me. I used to do a lot of Common Lisp game programming way back in the day. I did a lot of some early contributions to some of the SDL2 wrappers for Common Lisp too. Yeah. But no, I haven't done that in a while. It's a popular color scheme, I guess. Yeah, so we update simulation to a state T. This refactor let us remove some increasing indentation. As we were pattern matching on every collision case. Deeper. Yes, that's how we want to do it. Okay, this all looks good. So, if this is your first time tuning in, like Nixflix, welcome. All the code that you've seen tonight is available up here on the GitHubs. And yes, I use Emacs because it's a great operating system and has a pretty decent editor and other stuff. But more than that, it is more of a programming environment than it is anything else, which I like. So the code here is up on the GitHubs. I'm Agent Ultra. That's the repository for LambdaTrek, the project we're currently working on this stream. A Star Trek/Super Trek clone written in Haskell using the wonderful Brick library and a couple of other nice quality of life Haskell libraries we haven't really used before on the stream, like lenses and such. So yeah, it's been nice to work on. I do these streams once a week on Tuesday evenings, usually 10 after 8 in the Eastern Standard Time Zone. So if you want to follow along, you can just follow that schedule, or you can like subscribe and follow and do all the things here on the Twitches. And if you're watching on my YouTube stream, our YouTube channel, because you're in a different time zone or you're just playing catch up or whatever, you know what to do there as well, and like and subscribe and all that stuff. Because, you know, things, the internet stuff, how it works. Yeah, also check out the Discord link above here, or the link up here to the Discord. We'll lead you to the Discord, where we have a channel for this stream as well as others. Cool people doing programming in other languages that are similar to Haskell, declarative, functional sometimes, who knows. But yeah, you can ask your questions there you didn't want to ask on stream or asynchronously. It's all fun and games. I'm also on the socials on Mastodon. I'm on the types.pl server. I'm Agent Ultra there as well. You can follow me. Send me a toot. And other places as well, mayhaps. It's been a pleasure. May your monads always be free, your types always check. And let's maybe see if we can find a stream to raid somewhere here. Yeah, I do work at Mercury. Nix is pretty popular there. We do Nix stuff. And use it extensively. I am not the best at it. I've been meaning to get better at it for a long while. Strager looks cool. We should do that. How do I do that? I'm not very good at the twitches, so I'm trying to get better. I think it's in here. Yeah, there we go. Okay, Strager's pretty awesome. C++ developer. Really smart. It's been in the biz for a long time. So let's go. Let's do it. Sweet.
Let's see. I have an idea, but I don't know